the next two problems I'm going to do for sample size, there's two different formulas depending on if the problem is a mean or a proportion. And so that helps you decide what your formula will be. The first one, the mean, is this problem here. SAT scores are distributed with a mean of 1,500 and a standard deviation of 300. You are interested in estimating the average SAT score for the first-year students at your college. If you would like to limit the margin of error of your 95% confidence interval to 25 points, so E is 25, how many students should you sample? We know our standard deviation is 300. We need Z. Now, alpha is 1 minus the confidence interval, and we want 95. So alpha is 0.05. To find alpha over 2, we go into distribution and down to inverse norm. So it was second in this button to get distribution, and down to inverse norm and hit enter. And then you type in your alpha over 2. We said alpha was 0.05, so put 0.05 divided by 2 and hit enter. So our alpha is 1.96, because this 9 would round, so 1.96. Then to find your sample size, it's Z times our alpha, which is 300, divided by our error, which is 25, squared. And so if we put that into the calculator, there we go. 1.96 times 300 divided by 25 squared. And you get 553.19. You always round up no matter what your decimal is, or you won't be within the area that you want. So it's 554. Another problem, this one here, deals with proportions. So instead of the mean formula, we use proportions. You work for a marketing firm that has a large client in the automobile industry. You have been asked to estimate the proportion of households in Chicago that have 2 or more vehicles. You have been assigned to gather a random sample that could be used to estimate this proportion to within 0.03. That's our error. With a 99% confidence interval. Well, we'll need Z alpha over 2, so alpha, 1 minus 99% confidence interval, is going to be 0.01. With no prior research, what sample size should you gather in order to obtain 0.03 margin of error? Now in this case, they didn't give us a proportion or a p-value, so the largest possible is if this is 0.5, because then this would be 0.5 times 0.5. Any other one, you're going to have smaller values. And 0.3 times 0.7, 0.2 times 0.8. So halves gives you, if they don't give you a proportion, you use a half. And let me just double check. Yeah, the first part did not. The second part does, but the first one did not. So P, you're going to assume is 0.5. So we take Z, we have to find our Z. To find Z, we go back into distribution. So second distribute down to inverse norm and hit enter. And then we put our alpha, which was 0.01, divided by 2, and hit enter. So Z is 2.5 0.576. Don't worry about the negative sign because it's uniform. It's either way. This just always does below. So we have 2.576 divided by our error, which is 0.03 squared, times 0.5 and 1 minus 0.5. Plug that in. Two 0.576 divided by 0.03 squared times 0.5 times 1 minus 0.5. And hit enter. So 1,840 and round up 44. And that's what they have here, 1844. So that would be the most if you didn't have a proportion, a p-value. Now, the second part, I think will give us a p-value. Your firm has decided that the plan is too expensive. That's a lot. And they wish to reduce the sample size required. You conduct a small sample and obtain a proportion of 0.19. So the only difference, our p, is 0.19. So then for a formula, 2.576 over E So in this one, they took a small sample and found a proportion. And don't forget this is squared. Now what's nice, if you do have the TI calculator, you can hit second and enter, and it brings the problem back up. We make this a 19, and we go here, and put 1, and then insert a 9. And we get 1135, and that's exactly what they had here. So for a proportion, use this formula, and for a mean, use this one. And the z values, as long as they're the basic values like these were, there's tables online that you can look at for these numbers. So you could have them with you.